Yeah, never mind.
أسعد الله مساءكم وأهلا وسهلا فيكم بالجلسة الثالثة باليوم الأول من مؤتمر الهندسة الدولي للهندسة الطبية الثالث. المحاضرة اليوم بحث علمي مقدم من محمد الخليلي والدكتورة رفيدة حسين. عنوان المحاضرة Developing a Multi-Keel Prosthetic Foot Static Analysis Simulation. محمد الخليلي هو طالب هندسة طبية في السنة الرابعة من جامعة الأندلس الخاصة بالعلوم الطبية. طبعا الدكتورة رفيدة معروفة، هي دكتورة خريجة جامعة دمشق قسم الهندسة الطبية، وهي هلا تعمل في جامعة الأندلس على سبيل الإعارة حترجع لجامعة دمشق. تفضل.
In the beginning, I will introduce myself. My name is محمد الخليلي, a fourth-year student in the Al-Andalus University for Medical Sciences. And this is our research about developing a multi-keel prosthetic foot static analysis simulation under the supervision of Dr. Rufayda Hussein. Here we have, first of all, the contents. We will talk about the contents. We have introduction, literature review, methods and materials, result and discussion, and conclusion. And finally, we have the references. Introduction. Around the world, we have an increasing number about the cases of the patients that has a need of prostheses or splints, and this is according to the World Health Organization. But here in Syria, locally, we don't even have official statistics. Now, if we want to move to the types of the prosthetic feet, we categorize it into three main types. First of all, we have the conventional, the most basic type, the oldest type. Then we move to the ESR. ESR means the energy storing and releasing at the different levels of the gait cycle. It's the most dynamic, the most advanced in our department, and common in our country. Finally, we have the bionic side. The bionic, it's about a combination between the mechatronics, electronics, and biomechanics. Sorry, the bionic prosthetic is the most advanced, the most efficient, but at the same way, at the same time, it is the most expensive. The keel. The keel, it is the fundamental constitution of the prosthetic. It would be neither a multi-keel or a single keel. The multi-keel functions as the skeleton of the prosthetic and simulate the role of the muscles too. And this kind of combination between keels make the ESR level higher and higher. Now, if we move to the classification of the prosthetic or the prosthetic side in favor of the keel, we have, according to number, neither to be a single keel or a multi-keel. According to the articulation, we have non-articulated and articulated. Yani articulated, we have a joint in the prosthetic. Finally, we have the design principle. The design principle. We have two main design principles that we should mention. The first one is rollover shape, and the second one is leg trajectory error framework. The first one focus on the ease of motion of the center of pressure from the backside to the forefeet. While the leg trajectory error framework, it's about correcting the errors of the gait cycle of the abnormal or abnormal prosthetic and correct it repeatedly to have the most mimic or the most similar prosthetic or limb as the normal limb. Researchers found some problems in the suggested ESR prosthetics. The main problem is about it is only for K4 level patients. while we are focusing on the 2K or 3K and 4K levels in our study. It provides only one area to contact the ground, and it's high cost because it is made from carbon fiber. So the aim of our research to simulate the mechanical static analysis to design a multi-keel sport prosthetic foot manufactured from different materials to reduce the cost. We are focusing on reducing the cost because we are considering as a low-income country, and this is the basic or the most significant idea to be mentioned. Literature review. Our reviews are classified into two main groups. The first one interested in the design, and the second one interested in the best selection of the materials. The design side, we have already mentioned that the design principles and the number of the keels. So it's neither to be a single keel or multi-keel in different kinds of design principles. Materials used. We found various types of materials that are used in the prosthetics manufacturing process. We have composites, different types of glass fiber, metals and alloys, and polymers and plastics. If we move to making a comparison and our references studies, first of all, we have a study by Muhsina, computer testing of the effectiveness of using glass fiber reinforced polymer and design of running limbs type cheetah foot. It is studied about the possibility of designing or recreation a cheetah foot from another material than the carbon fiber to reduce the cost and at the same time maintain the mechanical properties. They used S2 glass fiber reinforced polymer, GFRP, and static and fatigue tests were applied. And this is all by using SolidWorks. Now we have the results, they have the results. The limb withstands force applied on the 4 feet, a force of up to 4,300 Newton. And after this number, the prosthetic moved to the plastic area of the stress and the strain curve. Withstands cyclic loads up to more than 2 million fatigue cycle. The criticism or the problem that we've found that it provides only one area to be touched the ground, so it is not the ideal design for standing. The second study by Shear to investigate the effect of increasing the number of carbon fiber layers on the performance of a multi-keel prosthetic. ما بيرفعهم؟ تمام. ننزل نحن. طيب. The aim of the study, it's about studying the possibility of reducing the amount of the carbon fiber layers and reinforcing it with an epoxy layers. It's all about reducing the cost and maintain the efficient side of the prosthetic. Here we have some special tested procedure. The results of this study, we should mention that the thickness of 10 layers of the carbon fiber and epoxy are enough to maintain the same mechanical properties. But we have a special condition here. If we preserve the conditions of the procedures, the test procedures. The problem here, high manufacturing cost because it needs a special conditions in the manufacturing process. Here we have some other studies about that interested in the center of pressure movement design, and the other one is about testing another materials that has a low cost, like polyterephthalate, ethylene, and rigid PVC. Methods used. The design. Our design based on the company of Roadrunner. It's a design. It's a road walking foot. Some properties of our design: multilateral short rise and designed from 4 carbon fiber layers. we talked about the most significant properties. Our editing or our changes in the lips or our changes in the prosthetic design, the superior keel, we replace the couple keels of, couple laminates of the superior keel into a single laminate with a thickness of 3 millimeter. Now, while the inferior keel becomes 4 millimeter and the posterior keel becomes 6 millimeter, and this various numbers of thickness gives the prosthetic a more the prosthetic limb a more efficient and higher rate in storing the energy than releasing it in the different level of the gait cycle. Here we have the design done by our team, our research team, by SolidWorks 2017. The limb is designed. For an impute, and this is information of our patient, and we can establish the dimensions of the prosthetic. Here we have an engineering drawing of each keel. Here we have the superior keel, the posterior keel. Posterior keel here functions as the soleus Achilles tendon, and it has the main role in ESR principle, performance. Finally, we have the inferior keel, defines the calcaneus and forefeet. Here we have the tests or the simulation. The test contains 4 main steps. First of all, we selecting the material. We try to select the best material, the most modern material, and have at the same time new studies. Determine the boundary conditions, and it's all by SolidWorks, the fixation area and force application area. The third step was about dividing the body into a mesh of nodes. It is the most significant idea about the finite element method, to dividing a body into a mesh of nodes and study the force up all the nodes, and has the result. Finally, we have determined the criteria for evaluating the body design during the analysis. We measured the stress and strain and displacement. The materials, we decided to take 3 main materials: POM, polyoxymetalat, acetylcopolymer. We all know that POM used in the short keel in Seattle food. The second one, cobalt, is a 3D printed metal. And finally, we have the GFRB. GFRB to make a comparison with the study of Muhsina. Why POM? Why do we decide to take POM? Because of many properties, many special ideas. First of all, we have a good fractional properties. We have availability of the modern studies of its procedures suitable to be in a keel, in the prosthetic keel, and finally affordable as it is made as a polymer material. Here we have some mechanical properties. A table shows it. Then here the simulation side, the boundary conditions. We can notice that the boundary conditions focused on or around the adapter side. Here we have the force of 700 Newton, and this number according to the body weight of the patient, heel and heel strike, and mid distance, and in the toe off or the end of the stance phase. We studied in the most important levels of the gait cycle. Now we moved to mesh or the finite element method. Each element size 5 millimeter, and the degree of deviation was 2.5 millimeter. Results and discussion. Here we have some measuring of stress and strain and displacement in heel strike by BOM and cobalt in mid stance and toe off finally. And this is a table shows our result with our combination between cobalt and BOM. And the other table shows the GFRB for the comparison with the study of Muhsina. And finally, we have noticed that the highest values of the stress were concentrated around the screws holes in the inferior and the superior keel in both material combination. So we decided to rethink about the screws holes and the screws material, as it is made from another types of materials, metal and its alloys. These values indicate to think about the improving the curves of the superior and the inferior keel and rethink of the screw sizes. Conclusions and future prospects. The combination of cobalt and POM acetyl polymer needs more study and advancing kinds of testing to have more specific or more efficient results. GFRB had a good result in the study of Muhsina for a single keel with a thickness of 10 millimeter, while our study has a various types or various numbers of the thickness. So we decided to rethink about the thickness side and the curves of the keels. Finally, the future prospects, we decided to take advantages of the artificial intelligence to make our prosthetic limb more suitable for the market, more suitable for the affordable side and prospects. We decided to use the topology optimization method for the thickness effect, and finally the multi-objective genetic algorithm for the best selection of the material. And here we have the references. And thank you.
الله يعطيك العافية. بحث حلو ممتاز متميز وفي شغل. هلا أنا ما كتير مع النمذجة، بس يعني بحث يعني ممكن هلا بداية النمذجة بعدين نطور. هلا لاحظت إنه أنتم أخذين 700 نيوتن خلال هيل سترايك وميد ستانس وتوقف والصور، ما هيك فهمت أنا. هلا نحن عنا في يعني في احدى المقالات حاطه انت كانت 4000 وشوي نيوتن بمقدمه القدم بتذكر. يس. عرفت كيف طلعت معهم ولا ما؟
لا، هن كانوا مدرجين دراسه للمهندسه محسنه، كانوا مدرجين كامل تيبل فيه كامل القوى من 700 نيوتن ل تقريبا ل 5000 يمكن بتذكر. فكان في قيم بتوضح حد الاجهاد وحد والانتقال للطور البلاستيكي والانهيار فاينل يعني. فكان في حاطين تيبل كامل بكامل القوى المختبره، كان كلياته اختبار حاسوبي.
تمام. اخذين انتم كتله الشخص هو 70 كيلوغرام وبالتالي النتيجه هي 700. اخذتوا بعين الاعتبار موضوع السرعه وازدياد السرعه وتناقص السرعه والى اخره. الموضوع هذا اخذتوه بعين الاعتبار ولا ما درستوه؟
هلا هو بالادفانسد بيرسبكتيف دكتور، لانه كان يعني نحن هلا دراسه استاتيكيه، لما مخططين ان ننتقل للدراسه الديناميكيه، كنا مخططين ان ننتقل للدراسه الديناميكيه بمستخدمين التقنيات المختلفه، بس هلا اكتفينا بالموضوع الاستاتيكي بثلاث مراحل اساسيه.
الله يعطيك العافيه. اذا في شي سؤال واحد بس بعد اذنكم لان الوقت كثير عندكم شي سؤال؟ ما في اسئله؟ شكرا كثير ويعطيك العافيه. ما
دكتور زهير
تفضل دكتور. هلا صوتك عالي دكتور انت.
هلا بدايه طبعا الشغل يعني كثير
وين المايك
هذا الثاني تسلسل بحث علمي جيد جدا. شلون؟
شغلي
أحمد لا تلك عن مكسر.
خلاص ما في مشكلة.
مش حال.
تمام. فبداية العمل كتير منيح. أنا طبعا مع الدكتور مصطفى إنه نحن النمذجة تحتاج إلى ما بعد النمذجة، لكنها خطوة جيدة وضرورية. هلا أنا بس بالنسبة للحمولات كتير أنت أخذها كحمولات ستاتيك فقط. تمام، لأنه لما ناخذ دايناميك، وهذا بجوز سبب 4000 اللي أخذينا بالدراسات، الدايناميك تتضاعف، وخاصة كلما ارتفعت السرعة أو ركض أو قفز.
تمام.
هلا بس أنا في عندي ملاحظة، أنت كنت دائما تقول لاختزان الطاقة stored energy
storing and releasing. ESR means energy storing and releasing. هذا يعني مرجعي الشيء.
لأنه هون نحن بهي الأنواع نحن دائما في عنا شك إنه السؤال هي يعني كيف تختزن الانرجي.
هون في عنا الاستخدام الذكي دكتور للمواد. احنا يعني احنا ما توسعنا شوي لضيق الوقت، بس كان في عنا الى حد ما اختيار ذكي بتموضع الماده. حطينا الماده البوليميريه بنسميها احنا بوستيريور كيل. البوستيريور كيل هي بتمثل وتر اخيل. تمام. فنحن صار يعني نحن قررنا هذا الشيء نعمله مشان عمليه اختزان الطاقه، لانه البوستيريور كيل هي الوحيده اللي بتكون ملامسه للارض بكل مراحل او تقريبا يعني ب 50% او عفوا ب 90% من الستانز فيز. فنحن اخترنا تكون ماده بوليميريه ذات معامل مختزنه للطاقه بشكل جيد مشان تعطيني افضل اداء باختزان الطاقه وتحرير الطاقه بنهايه طور التلامس. نحن اعتمدنا بهذا الشيء على موضوع تموضع كونه مالتي كيل يعني، فنحن على تموضع البي او ام اسيتال كوبوليمر.
انا بس بدي اعتذر دكتور زهير، وصلنا هلا اونلاين محاضره.
خلاص
يعطيك العافيه. شكرا كثير دكتور. شكرا.
بالختام بدي اشكر الدكتور رفيدة حسين على الفرصه الجميله، على الجهود المبذوله معي كطالب انا سنه رابعه. بدي اشكر كل من اتى وحضر المؤتمر من اهلي واقربائي واصدقائي وجميع الاساتذه المشرفين، وباخص بالشكر والدي ووالدتي واختي. شكرا.